Hello viewers, in today's class we are going to discuss a very conceptual problem from differentiation involving modulus function, right? And here we have a very interesting problem in which we have to find the derivative of this function f of x, which is the mod of sine x minus cos x at these 2 points, right? That is x is equal to pi by 6 and x is equal to pi by 3, right? So in this lecture we'll see the concept and how to find out the derivative of mod functions utilizing the definition of absolute value function and the graph of sine x and cos x. So let us first consider the graph of sine x and cos x, right? So here we'll draw a rough graph of sine x and cosine x on the same coordinate axis. So here we have the axis, x-axis and y-axis, right? So let us first draw the graph of cosine x, right? So the graph of cosine x, it goes like this, right? And the graph of sine x, it goes like this, right? So here we have the graph of sine x, right? So the red graph shows the graph of cosine x and the green curve shows the graph of sine x. So now this is the graph of sine x and this is the graph of cosine x, right? And here we have the origin 0, here we have plus 1 and here we have pi by 2 and the point where this red curve and the green curve intersect, this point is pi by 4, right? Okay, and here we have pi, right? So this is the graph of sine x and cosine x drawn on the same coordinate plane, and this point is the point of intersection of sine x and cosine x. So when we take this term which is inside the mod function symbol equal to 0, that is when we take sine x minus cos x is equal to 0, we get sine x is equal to cos x, and this is sine x over cos x is equal to 1. So this is 10x is equal to 1, right? And 10x is equal to 1 implies that x is equal to pi by 4, right? So here we have this point pi by 4, which is the intersection of sine x and cosine x. Now let us quickly see the definition of mod function, right? Now we have seen earlier that mod of p is defined like this, that is mod of p is positive p whenever p is greater than or equal to 0, and mod of p is equal to negative p whenever p is less than 0, right? So in this problem, when we find the derivative of fx, we need this definition of mod function. Now viewers, let us consider the interval that is 0 to pi by 2, right? And here we'll consider the sine x and cosine x, right? So now see, this function sine x is an increasing function. It is an increasing function in x belonging to 0 to pi by 2, right? Because see, the derivative of sine x, the derivative of sine x is equal to cos x, and cos x is a positive quantity when x belongs to 0 to pi by 2, right? And we know that a function y is equal to f of x is said to be an increasing function if the derivative is greater than 0 for all x belonging to the given interval, that is the domain D, right? So here for this problem, we should know that sine x is an increasing function in the interval 0 to pi by 2, because the derivative of sine x is cosine x, and this derivative is positive in the interval x belonging to 0 to pi by 2. Now similarly we can see that the cosine function is a decreasing function in the interval 0 to pi by 2, right? Because see the derivative of cosine x. The derivative of cosine x is negative of sine x. And we know that sine x is positive when x belongs to 0 to pi by 2. But here we have negative of sine x. So negative of sine x is negative quantity when x belongs to 0 to pi by 2. Because we know that if we have a function y is equal to f of x, and if f prime of x is less than 0 for all x belonging to the domain, then the function is said to be decreasing function, right? So cosine function is decreasing function and sine x is increasing function, right? So these concepts are required whenever we deal with problems of this kind. So now let us take the first part. So here we have x is equal to pi by 6, and pi by 6 is 30 degrees, right? And 30 degrees, it lies towards the left of pi by 4. Pi by 4 is 45 degrees, right? So when we take x is equal to pi by 6, then we can see that suppose this is pi by 6, right? So this point is pi by 6, and when we take pi by 6, we see that this is the value of this sine x, right? Because this green curve shows sine x, so this value is sine x. And now if we take this point to this curve, that is if we increase this line to this curve, that is the red curve, which is the curve of cosine x, then we can see that this value, it represents the value of cosine x, right? So this value is representing the value of cosine x, right? So cos x is greater than sine x when x belongs to the interval 0 to pi by 4, right? Now see, here we have seen that this point is 30 degrees, right? And this value gives the value of sine x, right? And if we take this point to this curve, then we have this line which represents the value of cosine x, and obviously cos x is greater than sine x when x belongs to 0 to pi by 4. So viewers, always remember that cosine x is greater than sine x when x belongs to 0 to pi by 4, right? Now if we take this cos x to this side, then we have 0 here, then we have sine x minus cosine x, right? We can also write it as sine x minus cos x is less than 0, right? So it means sine x minus cos x is a negative quantity when x belongs to 0 to pi by 4. So now by using this definition of mod function, we can write f of x is equal to a negative of sine x minus cos x, right? Because mod of p is equal to negative p when p is less than 0, right? And when we take this interval x belonging to 0 to pi by 4, then sine x minus cos x, let us take sine x minus cos x as p, right? So p is less than 0, right? So mod of p should be equal to negative of p, right? So mod of sine x minus cosine x should be equal to negative of sine x minus cos x. So now we can write it as minus sine x plus cos x, right? Now let us differentiate both sides. So we have f prime of x, that is equal to negative of cos x, and here the derivative of cos x is minus sine x, right? So differentiating f of x with respect to x, derivative of sine x is cos x, the derivative of cosine x is minus sine x, and we want to have the derivative at this point. So we can substitute x is equal to pi by 6 in this uh, expression. So we get f prime of pi by 6 is equal to minus cos pi by 6 minus sine pi by 6, right? So cos 30 degrees is root 3 over 2, and sine 30 degrees is half, right? So this is minus 1 plus root 3 over 2, right? So the value of f prime of pi by 6 is equal to negative of 1 plus root 3 over 2, right? So here in this part we have used that sine x minus cosine x is less than 0 because cos x is greater than sine x when x belongs to 0 to pi by 4. Now let us consider this part B. So here we have to find f prime of pi by 3. So x is pi by 3. So pi by 3 is 60 degrees, right? And pi by 3, it lies towards the right of pi by 4. So let us take pi by 3 somewhere here. So this point is pi by 3, right? So now let us see the value of sine x, right? Now see, this point is pi by 3. So now we have to consider the interval that is from pi by 4 to pi by 2, right? So earlier we have seen the interval 0 to pi by 4. Now we'll consider pi by 4 to pi by 2. So when we take this interval, and here we have the point pi by 3, and if we draw a line like this, and if we increase this line to this curve, that is the green curve, then we can see that this value is representing the value of cos x, right? And this value, that is the entire value, this value, that is this one, right? So this one represents the value of sine x, right? Because the green curve is for sine x. So we see that when x belongs to pi by 4 to pi by 2, then the value of sine x, is greater than cosine x, right? When x belongs to 0 to pi by 4, then the value of sine x is less than cos x, right? But when we go from pi by 4 to pi by 2, sine x is greater than cosine x, right? Because see, this value is greater than this one, right? So now from this inequality, we can see that sine x minus cos x is greater than 0, taking cos x to this side, right? And sine x minus cos x is greater than 0. It means if we take this quantity as p, then p is greater than 0. That is, p is positive, right? So whenever p is greater than 0, then mod of p is equal to positive p. So in this case, f of x is now equal to positive sine x minus cos x, right? So now differentiating both sides with respect to x, we have f prime of x is equal to cos x minus sine x, because the derivative of sine x is cos x, derivative of cos x is minus sine x, right? So this is cos x plus sine x, right? So now f prime of pi by 3 is equal to cos of pi by 3 plus sine of pi by 3, right? And this is cos 60 degrees. Cos 60 degrees is half, and this is sine 60 degrees, that is root 3 over 2. So this is equal to 1 plus root 3 over 2, right? So viewers, this is how by making use of all these concepts, we can find out the derivative of f of x is equal to mod of sine x minus cos x at these points.